This lesson was a Unit 4 third grade lesson involving revisiting problem solving related to multiplication and division. During the lesson open, up to 20% of the lesson, which for this hour-long lesson was approximately 10 minutes, several key features of an open were completed. First, the students were introduced to the learning targets for the day, including using the structure of their number system to solve problems related to SMP 7, as well as persevere when solving 1 and 2-step problems related to SMP 1. The kids activated their prior knowledge, talking about multiplication and division strategies that they had used in previous units, using specific focus vocabulary, including multiples, strategies, and proof that we encourage the kids to use throughout the lesson. Kids then previewed the 2 problems that were completed, as well as specific success criteria. We reviewed directions for partner work and a really important aspect of building voice and choice in. We encouraged kids to remember all of the tools and strategies that they had been using throughout prior units and encourage them to make choices with their partner during their work time to find the tools and strategies that would work for them. Following questions that were answered by the students, the kids moved into the work session, or the 60% of the lesson.
Was going to split, so one gets 4 and the other gets 4.
So you're each going to do 4?
Yeah, so
Okay.
like we split it in half, and then if we want to, we have all this extra space.
Okay, all right, get to it.
Okay, I'm also going to, so I'm going to do the top and you can do the bottom.
Okay.
Okay, so let's start with. This is going to be 70.
20, 40, 60, 80, 100, 120, 140.
Set 140 for this one?
Yes.
Then
50
this one,
times
I
5
don't know
times
what
50.
this one. 50, 100, then
Then we have 150,
no,
200, 250.
Hold up. Yeah, 200.
So what strategy are you guys using?
We're using the fingers that we have.
Your fingers? And what are you doing with your fingers?
We can also do,
We're counting up, and we can also
so, and the way I said, we can also use this big space.
Okay, but you guys aren't using the space today? You don't need it?
Well, we're going to use it if we have to.
Got it. Okay. All right.
$100. That's 1, 2, 3, 4, 5 20s. That's 100. Plus a 20, that's 120. And then plus another 20 equals 140.
But remember, we don't know if it's times,
Or it's
division, plus, or subtract.
so we know it's definitely not contraction because we're doing 6 rows.
So I'm going to do this plus 5 and
times.
So it's not going to be that. And we definitely know it can't be division because those are the same thing. So it's either adding or subtraction or times.
It should be times or adding. It should be times because we're times the 20s equals the 140 I just did.
So that means it can't be this.
So it should
So it should be multiplication.
But you guys did addition, so tell me why you did addition and or why you're now thinking about multiplication. So how does that shape your thinking?
We're going to times the 720s and put them into rows.
Okay, go ahead and work on that, and then I'll come back and see your proof in just a minute, okay?
What do you have?
Basically, we learned how, because it said 7 rows, so then we did 7 in each. So basically, we turned that 7 into columns, and then it showed 20 for each row. So then we had to use 3 bags, and yeah, we
Had to use a lot, didn't you?
yes.
Okay, so you have a concrete array for your proof.
Yes.
I'm gonna have you, what was your final answer? How many chairs does the engineer need to get?
140.
140 chairs. So I want you to look at how these two mathematicians solved. How is this similar or different than your proof? So take some think time for just a minute. How is that similar or different from your proof? Okay. Talk to somebody right by you. How's that similar or different to your proof?
It's different. They swap even though but it is also kind of because you can mix the colors into the and then you could
All right, finishing up that conversation, who would like to share how this is similar to their strategy? Used a different strategy or a different proof, but it's similar.
Me and Padme did the same, but we didn't do any spaces.
Okay, so you did getting closer to a rectangular model.
Yeah, but we did not finish.
Yeah. One of the challenges with concrete when you're doing big numbers is it's hard to get it all done, right? And to keep it straight. There's a lot to do. That's why we like numbers in math, because sometimes they're a little bit faster. But what I love about these similar models is it's easy for me to really see what it would look like in the real world. Like I can picture each of those being a chair, okay? So that's easier. It's important in math to be able to see what the number story is really telling you, okay? All right.
So we would have, because we know that 10 plus 10 equals 20, so we left a space right there and we had 7 times 10 on this side and 7 times 10 on this side. And then we know that 70 times 2 equals 140 because 10 times 7 equals 70, and we know that 7 plus 7 equals 14. So if we add the 0, it would equal 140.
Okay, so this is different than what we saw over here. So over here we see a concrete array that's a solid set, 20, 20, 20, 20. This is really similar, but a little bit different. Do you see the difference? Okay. So you have two arrays of 70 and 70. Turn and talk to somebody right by you. Why does this make sense related to the problem?